Write the following sum with summation notation. Do not calculate the sum. So they're giving us, fortunately, a little more information here. Let's start out by counting I equals 1, 2, 3, 4, 5. So my B is 5. And let's look at what is not changing. Okay, so in each of these terms, we have a 3 plus, okay, so the number in the numerator is changing, but x isn't changing, and also my exponent is changing. Now, if I look at the exponent on the first term, it's a 0. Pretty easy to see that this is just I minus 1. I've got now let's look at the other number that's changing. 3 goes to 5, which goes to 7, so we're multiplying by 2 here. So 2 times I. So with I equals 1, I'm going to get a 1 here. That's going to give me a 0. I'm going to have a 1 here. I have 2 times 1, which is 2. To get the 3, I would have to add 1. So I'm pretty sure the pattern is 3 plus 2I plus 1 all over x to the I minus 1. I'm going to check it with my last term though. So when I equals 5, I get 3 plus 2 times 5 plus 1. That'll definitely give me the 11 in the numerator. And then 5 minus, 5 minus 1 is 4. All right, so that's definitely my pattern. Okay, getting close to the end here. So we have a couple of applications. After 1 day, a colony of 500 bacteria reproduces to become 200. So day 1, we got 50. On day 2, we get 200. And they tell us on day 3, we get 800. Now, these problems, all the variations of this problem is going to be pretty simple. It's pretty easy to see that we're quadrupling. So 50 to 200, we multiply by 4. 200 to 800, we also multiply by 4. So that means we've got some kind of exponential function with 4 as the base. So let's take a look, and we're going to need, so 4 is the base. So let's take a look at the numbers we have. And I have 4 to some exponent that probably involves I. And let's multiply it by our initial amount of 50. So in order to get, on day 1, in order to get a 50 out of that, my exponent needs to be 0. So if I have 1 minus 1 here, I'm going to get 50 times 4 to the 0 power, which is 1, which is just 50. Now let's see if that works over here. 50 times 4 to the 2 minus 1. So I'm just using the day as my index. 50 times 4 definitely gives me 200. And it'll work here as well. 50 times 4 to the 3 minus 1 gives me 50 times 16, which gives 800. All right, so we have a base 4, and all we got to do is use that idea to, let's move that up, to answer the question, which is how many bacteria will be present after 6 days? Well, 50 times 4 to the 6 minus 1 is 50 times 4 to the 5th. 4 to the 5th is a really large number, but when I multiply that by 50, I'll get 51,200 bacteria. That's all they want to know, the final answer. Yeah, I'm trying to spare you the lunch announcements, but I'm not always quick on the trigger. Okay, expand the summation notation and simplify rounding to the nearest tenth. This is a really straightforward. By the way, this was the last problem on the quiz. It was given in a context. The context doesn't matter. They're really just giving you an equation, and they're asking you to expand and simplify. So we're going to go between 1 and 5. that's I equals 1, I equals 2, I equals 3, and one last one at I equals 5. Okay, now what I found really interesting about this, because I simplified it and entered it into the quiz software. 2 to the 5th to the 0 power is just 1, so that's just going to be 8. Plus 8 times 2/5 to the 1 power, plus 8 times 2/5 squared. And move all of that down a little bit. Plus 8 times 2/5 to the 3rd power, and last 8 times 2/5 to the 4th power. So when I entered all that in, it asks you to simplify rounding to the nearest tenth, but when you enter that in, it's going to give you the decimal approximate of that. So you don't even actually have to pick up your calculator on this. Just pay attention to what you see when you enter it. And we are done with this lesson.